Hi everyone, let's continue with question number 11 on page 83 from the textbook. We're reviewing for unit number 1. The question says we have to find the values of x so that the tangent to the function y equals 3 over third root of x is parallel to the line x plus 16 y plus 3 equals 0. So always read the problem more than once if necessary. We don't have to understand things right away the first time we read them, so read the second time, and then the second time and the third time, if necessary again, you try to organize the information given and write it down so that you can better see the connections between what's given and what you have to find. So let's do this. Again, let's read the question and try to locate the information and what we have to and define what we have to determine. So we are asked to find the values of x. So there are points with coordinates x and y. We are asked to find only the x values so that the tangent line to this function, so we are given the function y equals 3 over the third root of x, and we need to find out where the tangent drawn on this function can be parallel to this given line. So x plus 16y plus 3 equals 0. So remember that this line in here is not necessarily a tangent to this function, so it's just some tangent somewhere on the grid. So for example, if you have some curve in here and you have some line in here, then you want to find out at what point on the graph you will have a tangent line, for example, on the function to be parallel to this given line right here. So to illustrate this, you can also try to graph both of them on decimals just so that you can better understand what the question is about. So we're going to start off with connecting the information given. So we are given this function and we want to find the tangent line that has the same, that is parallel to this one. So we are trying to find the tangent line here when we are given this line in here. So we're going to say that the tangent line that we're trying to find would be some line in the form y equals mx plus b. And what we want this tangent line to be is parallel to this given line. So what would be the connection between the tangent to this function and the given line? So when two lines are parallel to each other, it means that the two lines must have the same slope. So what that means is that the slope of this given line, I'm going to write given line here, would be equal to the slope of the tangent. So this would be the slope of a tangent line. So in order to figure out what the x value would be, so at what x value we'll have the slope of the tangent line equal to this, then we first need to identify the slope of the given line. So if you look at the equation here, this is in standard form. So when it's in standard form, it's not as easy to identify. There are patterns and formulas you can try to memorize, but memorizing is not the solution to every problem. So it's easier to convert this to slope y-intercept form, which means we have to solve for y. So we have negative x minus 3, and then y equals negative 1 over 16x, and then minus 3 over 16. So this is the number that we are interested in. So that's the slope, which is the number in front of x. So that tells us that this slope of the given line here, which is negative 1 over 16, must be the same as the slope of the tangent, which would be negative 1 over 16 as well. So what we're going to start doing, as you may imagine, is first find out what the slope of the tangent at any point is. Remember that this equation is not given in power form, and we haven't learned how to, again, find the derivatives when in rational functions. So we have to convert this equation to an equation with power term only. So this would be 3 over x to the power of 1 over 3, or even better, we're going to say this is 3x to the power of negative 1 over 3. Let's differentiate it. So dy dx would be equal to 3, and then coefficient will come to the front, negative 1 over 3 minus 1. And that would be equal to, simplify here, so 3 and 3 divide to 1, so that will leave just the coefficient negative 1 in front of x. And negative 1 over 3 minus 1 is the same as negative 1 over 3 minus 3 over 3. That makes it negative 4 over 3. So that means that the derivative dy dx equals negative x to the power negative 4 over 3. Or even better, actually, it would be to, since we are evaluating it very soon, it would be equal to negative 1 over x to the power of 4 over 3. Now remember that this would be the slope of the tangent. And the slope of the tangent, we said, would be equal to the slope of this tangent, of this line, given line. So that means that this value would have to be 1 over 16, and it's a negative number. So let's take another look at this equation and see how we can solve it. Obviously, this is not one of the typical equations we have solved in polynomial functions. This is completely different. So it's rational, and it also has rational exponents. You see that you have negative 1 in here in the numerator. These two fractions are equal, which tells us that the denominators are the same. So that's one way of approaching solving this. So x to the power 4 over 3 is equal to 16. Or you can simply cross multiply. It's the same idea. So negative 1 times x to the power 4 over 3 equals negative 1 times 16. So I would say this is a shorter cut. And now we have to isolate x. So you have to think, what do I want to isolate x from? I want to isolate x from the power, which is 4 over 3. So what do I want the power to be? Well, I want the power to be equal to exactly 1. So how can I make a 4 over 3 into 1? So you have to multiply it by the reciprocal of it, so 3 over 4. And if I multiply by 3 over 4, then what do I have to do to both sides of the equation? So you have to bring both sides of the equation to the power of 3 over 4. So we'll do that. And we're going to have 3 over 4 on this side and 3 over 4 on this side. And voila, we got x equal to 16 to the power of 3 over 4. Now I want to bring your attention to the power in here, 4. And I'm going to write this in radical form for a reason. So remember that. Let me write this down first. So the 4th root of 16 to the power of 3. Remember that when we have solved equations that, for example, had even power, so x squared equals 4, we said that x can be either plus or minus 2. Now the same idea applies to if you have x to the power 4 equals, let me think of a number here, so 3 to the power of 4, 81, for example. So x to the power 4 equals 81 would be the 4th root of 81. Now when you think about it, because you have an even power here, x could have been either a positive 4th root of 81 or a negative. So this is basically equal to 3. So we're going to say either 3 to the power of 4 is 81 or negative 3 to the power of 4 can give 81. So what I'm trying to actually bring to your attention here is the fact that when we find the eventh root of a radical of a number, right? So when we have a radical that is an eventh root in an equation, so we were trying to find x, then we have to take both the positive and the negative values. Do not forget, this is very easy to forget and overlook at, but we mentioned this now and we kind of, went over it. So I hope that you won't forget this on the test, obviously. So that what we have in here is the 4th root of 16 to the power of 3, which is basically going to be equal to 8. You can use a calculator for it, and or you can use, I can do it mentally. It's not that difficult because the 4th root of number 16 is equal to 2, and then 2 to the power of 3 will be 8. So therefore, we're going to say that the slope of the tangent will be, or the tangent line will be parallel to this given line at x equals 8 and negative 8. So there will be 2 points, right, where the tangent drawn will have the same slope. And I hope that you find this useful, and I hope you understand the steps. Go over it once you finish listening to the video, just to make sure that you understand the steps. And the best way to really make sure that you understand something is, after you go through a solution, try to create a chart of the steps that you had to follow, and try to see the logical connection between the steps. And that's the best way to develop your thinking skills, and not just, memorize the steps and whatsoever, especially when you are encountering questions that are new to you. All right then, so I'm going to leave it here. Bye for now, and thanks for watching.